This stage of the CHUMP build saw the AT28C16 EEPROM chip used for visual confirmation of the Chumpinese program written for the previous submission flashing on an LED bar graph. The EEPROM chip was burnt using the RSGC ACES EEPROM burner shield. The EEPROM burner works by loading the Chumpinese code written from the previous submission onto our EEPROM chip through the Arduino IDE. Visual confirmation of burning can be seen through a shift register and bar graph mounted on the burner shield. The astable and monostable modes on the clock can switch from running the code manually, with each press of a button resulting in the program advancing by one line, or automatically, with the frequency being adjustable using a trim potentiometer. Four output pins from the SN74LS161 4-bit counter IC are connected to the A0, A1, A2, and A3 input pins of the EEPROM chip, allowing the bar graph to display values for the first address in EEPROM. Only the first four address pins are used, as they correspond to the first four bits on the EEPROM. So when the other six address lines are wired low, only the first address can be read or displayed. All 8 I/O pins from the EEPROM chip are connected to the bar graph, allowing the code to be burnt into the first address and to be read and displayed. When the CE and OE pins receive a low signal and the WE pin is wired high, the data stored in the memory location determined by address pins, in this case address 0, is asserted onto the outputs. The other 127 programs can be accessed by setting the other 7 address pins to high or low. As they are wired low, the address 0 is being read. The next portion of the video will compare the line of code being read to the display on the bar graph. When the reset button is pressed, the lowest and highest of the low byte is illuminated. When the counter button is pressed, only one bar is illuminated, representing the lowest bit of the program receiving a high signal and corresponding to line 2 on the program counter. The lowest byte corresponding to the first 4 bars on the bar graph always stays off, as we are always reading address 0. On the third line, only the second lowest byte is illuminated. If you follow the rest of the code through, it perfectly matches the machine-level instruction code shown on the table. The final 5 lines of the program illuminates all the bars on the bar graph until the program counter resets back to 0, as those lines of code are empty.